Okay. So next concept is about span switch port analyzer. So if you talk about switch port analyzer, right? So the switch port analyzer is used to monitor the traffic. Okay. So generally, it will be used in cases where you want to monitor the traffic. You want to look into the traffic that, okay, what is going on in the network. Okay. So with span, we can copy the traffic of an interface to another interface. Okay. So if I tell you one scenario or one use case of this, so let's say I want to deploy an IDS in my network. Everybody knows difference, right? There are two things. One is IDS and second one is IPS. Intrusion detection system and intrusion prevention system. Right? So these are used to, check the malicious traffic in the network. That means malware kind of things. Okay. So if your traffic is malicious, in that case, we use IDS, IPS kind of devices. So let's say if I'm talking about IDS can detect, okay, IDS can detect an intrusion attempt but cannot prevent. And if we talk about IDS, so IDS inspect a copy of the traffic. So that means if you want to deploy IDS, in that case, you use span. IPS is what? Can detect as well as prevent intrusion attempt. Okay. And your IPS inspect the original traffic. Okay, so let's say I want to deploy IDS in my network. So what IDS will do, it will inspect a copy of the traffic. So if I'm having a network like this, let's say, for example, a sample network scenario I'll take that I have internet, I have a switch, and then I have my LAN PCs. Okay, router is missing. So let me add the router also.
So if we want to keep a firewall, where we can place firewall
In place
to
of
internet?
place, you can place
After the router? After the router?
after the router also, you can place here on the switch also, you can place anywhere you can place. This is internet. This is my gateway. This is my switch. PC1, PC2. Now let's say what I want to do is I want to monitor or inspect my traffic, that what is going on in my network. So what I can do, maybe I'm willing to deploy IDS. Okay. This is my IDS. This is something I want to deploy. So let's say this interface is F0 by 1. This interface is F0 by 2, F0 by 3. Okay. And then I'll connect the IDS here. Let's say this is connected on F0 by 4. Okay. So now what will happen? Let's say if you want to monitor the traffic. So depending on what traffic you want to monitor, let's say if you want to monitor only the traffic that is going for PC1, then what I can do is I can copy the traffic of F0 by 2 interface and I can send it to F0 by 4. That means to my IDS. Same thing. If I want only for PC3, I will copy the traffic of F0 by 3 and send it to F0 by 1. But let's say I want to monitor or inspect the traffic of my entire network. So I know that, okay, my entire network traffic will be passing through F0 by 1. So I'll copy the traffic of F0 by 1 to the F0 by 4. Is it clear? That is your span concept. That span port is a port where that receives a copy of the traffic. That is going to receive the copy of the traffic. Is it clear? Yes. Okay. And the configuration wise also span is simple. Only like you have to give the source port and destination port. Command is you can say like monitor session ID. Okay. And then you can say source interface and interface name. Okay, let me verify the command. I might different iOS, it works differently. So let me see if it works here. In the switch, monitor session. Okay. Let's say session ID will give 1. Then you can see I can define source interface. Yeah. And I can give the interface name. So let's say I want to copy the traffic of F0 by 1 interface. Okay. F0 by 1. This is my source interface. Same way I can configure the destination interface where I want to send it. Destination interface, let's say F0 by 3 or 4, wherever you want to send it. Okay. This is the configuration. Now what will happen? Whatever the traffic, okay, even if I'll try to ping, right? Take a look. If I'll try to ping from PC, first of all, let me check they have the IP address or not. They have it. Fine. Now what will happen? Whatever the traffic will come on this F0 by 1 interface, automatically one copy of the traffic will go to the F0 by 4 interface also. So let's see if on the server I have anything to capture the packets. HTTP. No, there is no such thing as packet capture, but let it be. I'll show you in the simulation mode. So I have configured that, okay, the F0 by 1 traffic should be copied to F0 by 4. So from PC1, I'll try to ping the router. Okay. So if I say ping 10.1.1.1 and let me go to simulation, I'll capture the ICMP only. So you will see this will be a unicast packet. Okay. This is a unicast packet, but one copy of this traffic will go to the same packet that came here is also coming here. You see, this is what span, that any traffic that is incoming, outgoing of this interface, that traffic will, one copy of the traffic will go to the interface. See, every time one copy, every incoming and outgoing traffic, one copy will be sent here. This is clear. This is your span used to monitor. So the command is interface name, and only changes here destination. This is clear. Guys, clear? Right?
Yeah. Yes.
Okay. Then another concept we have is about the private VLAN. So what is this private VLAN concept? So if we talk about private VLAN, so this is used to restrict the communication within a VLAN. Okay, within a single broadcast domain, if you want to restrict communication, then we can use private VLAN. So private VLAN is used to restrict communication inside a single broadcast domain. Okay. So if you talk about private VLAN, there are two types. It is of two types, primary and secondary. We have primary and we have secondary. Okay. If we talk about primary, so primary is also known as promiscuous. Primary is also known as promiscuous. While under secondary, we have two categories again, two types. We have community and we have isolated. We have community and isolated. So simply understand that your promiscuous can communicate with community and private. Okay. It can communicate with community and private. And your community can communicate with another community. Communicate will be communicating with another community. But not with isolated. And your isolated can only communicate with promises. Okay. It can only communicate with promises. It cannot communicate with another. Okay. It cannot communicate with another. That means two isolated will not communicate and two community will communicate. Isolated and community, they will not communicate. Okay. And they both can communicate with the promises. This is how it is. Now, one thing you have to take care while configuring the private VLAN, that while configuring private VLAN, the switch must be in VTP transparent mode. Okay, this is something you need to take. Now, how do you configure them? So, first thing we will do, if we talk about the configuration. So, first thing we will configure is VTP mode transparent. Okay. Then you will say VLAN, VLAN ID. Then you will say that this VLAN belongs to private VLAN community. That means within a VLAN, we are creating sub VLANs kind of. Okay. So these are the sub VLANs we are creating. Same way, one VLAN I'll create that again. Like example, if I give you, so let's say I'll say something like 501. This is the community, and again VLAN ID. For example, 502. I can say private VLAN isolated. And then I can say VLAN ID. For example, let's say this is the 500, and I'll say private VLAN primary. Okay. And with this private VLAN, we will associate, we will say private VLAN association add. And what are the VLANs I want to add? So I want to add from 501 to 50. These are the ones I want to add. Now, whatever the interfaces are there, those interfaces we can add in relevant from private VLANs. How? Once we have created this, then we will say interface name. Then we will say switch port mode. This is the private VLAN host. Then after switch port mode, right, not mode. Switch port private VLAN host association. Okay. And the primary VLAN is 500 and the secondary VLAN is 501. Like this we do. Okay. And same thing we will do for the same thing you can configure for the isolated also. Same thing you can configure for, like let's say. So if I say like this, here you will give the primary VLAN. And here you will give the secondary VLAN. Okay. Then wherever you will configure the primary VLAN, so interface name. Then you will say which port mode private VLAN promises. Then we will map it. We'll say switch port private VLAN mapping, primary VLAN, then secondary VLAN. Okay, so overall thing is what? First of all, set the mode to transparent, then create your secondary VLANs and your private VLAN. Inside the private, I mean promiscuous or primary VLAN. Inside the primary VLAN, we will add the secondary VLANs. After that, wherever you want to add the secondary VLANs, anybody you want to configure as community or isolated. So we will just go to the interfaces, then we'll say switch port mode private VLAN host, and then we will add the host association. That okay, switch port private VLAN host association. Then we'll give the primary VLAN ID, and then you'll give the secondary VLAN ID. And then where is your primary interface? So through that interface, you will say switch port mode private VLAN promiscuous, and then we will start mapping the secondary VLANs. So let me show you practically so that you can understand what is happening here. Okay, go here. I need evenly for this. Or is it going to work here as well? Let me check the comments first. VLAN, no, here the command is not there. That command, private VLAN command is not there in the packet list. Okay, so this is the scenario where I have two PCs in the community, two PCs in the isolated, and I have one promiscuous. Okay, so if you see this server, this is just nothing but a router only. Okay, nothing special. One router, one switch, and four PCs are there. Let's start all these nodes. So let's take access. First of all, let's take access of the switch. Then take access of the router. This PC is not starting. PC3, PC4, PC5, PC6. Okay, so all are routers only. So understand the scenario here. Here I want that okay, everybody, okay, this VLAN like PC3, PC4, they should be able to communicate with the server. PC5, PC6, they should be able to communicate with the server. That means everybody should be able to communicate with the server. Okay. And this PC3 and PC4, they should also communicate with each other, but they should not communicate with the PC5, PC6. Then PC5 and 6, they should also not communicate with each other. That means this is overall one VLAN. Let's say VLAN 500. But within this VLAN, I have my restrictions that, okay, they should communicate, they should not communicate to each other, and everybody should communicate to the server. This kind of restrictions are there. So this is where private VLAN is useful. Okay. So first, let me assign IP addresses to everybody. So the server is having 100. Host name, server, interface, gate 0/0, IP address 192.168.1.100. Setup, PC3. So this is PC3 right now. PC3, PC3, IP address is 1.3. Then PC4 IP address is 1.4. PC5 PC6 okay. And as of now, I'll set all the ports of the switch to port pass so that we don't have to wait. Interface G0 by 023, G1 by 023, spanning tree, port pass. Okay, so all the interface is set to port pass. Now, as of now, if I will check, right, so everybody is able to communicate with everybody. Like if I talk about server, so think 192.168.1.3, they will be able to communicate. Okay, 1.3 is able to communicate, 1.4 is able to communicate. Okay, 1.5 is able to communicate with the server, 1.6 is able to communicate with the server. Then you will see that PC3 and PC4, they are able to communicate to each other, do thing like ping 192.168.1.4. So PC3 is able to ping PC4, it is able to ping PC5, it is able to ping PC6. Everywhere they are able to communicate. But I want that, okay, PC3, PC4 should communicate, but they should not communicate with 5 and 6. And also, 5 and 6 should not communicate with each other. Ping 192.168, 1.6. So right now they are communicating. But I want that they should not communicate to each other. Okay. So to achieve all this, what we can do is I'll go to the okay. Now see how we will configure private VLAN. Right now we saw that okay, everybody is having communication. So first of all, we will configure the VLANs. So let's say first of all change the mode to VKP mode transparent. This is done. Then we will say VLAN, let's say 501 and use the command private VLAN. And this is for, let's say, community. 501 is community. VLAN 502, private VLAN. This is isolated. Then I'll say VLAN 500, private VLAN, primary. Okay. And here now we have to add the host. So private VLAN. Okay. Then association. And what are the VLANs I want to associate? So I want to associate from 501 to 502. Or see here, VLAN IDs of the private VLAN. So 501 to 502. These are the VLANs I have associated. This is done. Now we just need to go and configure the interfaces. So like I can see here my switch interface Z0 by 1 and 0 by 2. They are part of community VLAN. That is 501. So I'll say interface range Z0 by 1, 1 to 2. These both are what? Private switch port mode private VLAN host. Okay. Switch port private VLAN association, not association, host association. Host association. Now I have to give what my primary VLAN. So my primary VLAN is what 500 and my secondary VLAN is what 501. Okay. This is done. Okay. Now I can see this side. that these two, 0 by 3 and 1 by 0, they are in the isolated. So interface range V0 by 3 and V1 by 0 through switch port private VLAN host, switch port mode private VLAN host, then switch port private VLAN host association. Primary VLAN is 500, secondary VLAN is 50. This is done. Okay. Then this Z0 by 0, I have to add it to the promiscuous or primary. So interface gig0/0 switch port private VLAN switch port mode private VLAN promiscuous. Okay, and then I'll say switch port private VLAN. Now we'll add the mapping, and I want to map the 500 with 501 and same 500 with 502. Now this is all the mapping done, and once this all mapping done, we are good to go. So now I can see that PC3, is it able to communicate with the server? Yes, it is able to communicate with the server. Is it able to communicate with PC4? Yes, it is able to communicate with the PC4. But is it able to communicate with PC5? So no, it will not communicate, because community and isolate will not communicate. So not able to communicate. Okay. And if we talk about PC5, so you see this is in the isolated VLAN. Is it able to communicate with the promiscuous? Yes, it is able to communicate with the promiscuous, but is it able to communicate with another isolated? So PC5 will not be able to communicate with PC6. So two isolated will not communicate to each other. Okay, and isolated and community, they will not communicate to each other. You can see, like if I think with PC3, they will not communicate. So what do we understand here? That here, these both, they are communicating with the server, but the isolated are not communicating with each other, while community are communicating with each other. Clear, guys?
Yes, sir.
All right. So this was your private VLAN concept. Okay, and with this, we have completed all the topics. So with this, your switching is completed.